So good morning everyone and welcome to this lecture. We are into second lecture of work, power and energy, and we are dealing with the basic definition of work and finding out how do you find out work done by various forces. We had seen work done is the dot product of force with displacement, or it is the integral of F dot dr. If force is constant, we can find it out directly by force and the displacement. The dot product of force with displacement will give us the work done if the force is constant. Do we remember this? Yes or no? Then we must also remember what we were doing in the last class. I think we were discussing a question in the last class, and this was the question that we were discussing. You have to find out the work done by gravity, work done by normal reaction, work done by the 10 Newton force, and work done by friction in 5 seconds. Did anyone try this question? Only one? No one else? One, two, three. Okay. Anyone got any answer for this? You still have 2 minutes to try again. If you don't try questions, you are not going to get answers anytime. And you might not be so lucky that the question that we are doing, the same question will come in the examination hall, because for that we'll have to do a lot many questions and we don't have time for that in the class. So if you don't try questions with your own hands, it's not going to help much. So I would urge you to try it. I give you 2 minutes to try it again. Everyone should try the question and you should be able to get the answer. If you're not able to get an answer of this question, that means something is not correct somewhere. The process is wrong. Whatever we are doing is wrong. You must be able to get the answer for this question. There are no excuses not for getting answer for this question. There are no excuses that can be heard. So I'll give you 2 minutes still to find out the answer for this question. Everyone should be able to get the answer for this question. There should not be any excuse that I could not get the answer. There is no excuse that has to be heard if you can't get the answer for this question. You must be able to get the answer for this question. You have 1 minute to do it. Just tell me, how are you going to do it? Anyone? How are we going to do this? What should be the first step? Tell me. What is the first step of doing this question?
F is equal to ma, sir.
F is equal to ma. So I'll write F is equal to ma. Now what? Now what is the next step that I should do?
N is equal to 5a. A is 2 meter per second square.
A is 2 meter per second square. Okay. Then what is the next step? I've written F is equal to ma and I written A is equal to 2 meter per second square. What should I do next?
V is equal to U plus AT.
V is equal to U plus AT. Okay. Now
V is 10 meter per second.
V is 10 meter per second. Okay. Now we are talking about work done, but that thing has never come. Anyone else? How to proceed further? No one knows? Great. Acceleration is coming as 2 meter per second square. How many of you got this answer? All the girls got this answer. How did you get this answer? Acceleration is 2 meter per second square. Can you tell me? How did you get this answer that acceleration is 2 meter per second square?
N is equal to 5 years.
N is equal to
5A.
what is N? N
Mass.
is equal to no. How did you get this answer as 2 meter per second square? That is what I'm asking, beta. How did you get it to 2 meter per second square?
Acceleration constant.
Yes, beta.
Acceleration constant.
Okay, so you think I don't know, but I can guess that you put here 10 and you put here 5 and you put here A and you got acceleration as 2 meter per second square, right? Everyone did this? Yes or no? Well done. That is what we have learned for the in the chapter on Newton laws, and that is exactly what you have done. Well done. So do you remember this? Great. Nothing like nothing better than remembering things that we have already done. It's a good sign that
Friction.
yes, beta.
Friction is there. Acceleration is equal to 1 meter per second square.
I'm not able to hear what you are saying. Not able to hear what you are saying, bacha. Sorry.
Sir, acceleration is equal to 1 meter per second square.
Acceleration is equal to 1 meter per second square. So I'm now getting two answers. One is 2 meter per second square, one is 1 meter per second square. How did you get 1 meter per second square? Straight
Sir,
away.
friction.
Huh?
Friction is also there.
Friction is also there. Friction is also there. Yes, that is correct. Friction is also there. So basically, up till now, whatever we have done, it's of no use because we don't understand what we have done. That means it's of no use. The first thing that we do in every question that we have done from the very first class is to draw something known as a free body diagram. That thing is missing. Where is it? Oh, free body diagram. So that is what we do first of all. We draw something known as a free body diagram. We draw a free body diagram. This is 50 newtons. This is normal reaction. And we have done this, Tim. Does this thing 50,000 times I have done this. 50,000 times I have done it. So that one day you will be able to do it on your own. But that day is still not coming. Anyways, n is equal to 50 because it is not going to go jig, 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 jig. But then there is a force in this direction, and therefore this body is going to accelerate in this direction. Now, if this body is going to accelerate in this direction, there is friction here. Friction is going to oppose it. So, frictional force will be acting in the opposite direction. And the value of this friction is kinetic. Do you remember kinetic friction? We have done questions on kinetic friction. That chapter is already over, but that doesn't mean that we forget it. The chapter is gone. Forget it. New day, new beginning. This is physics, my dear friend. There is no new day, new beginning. It depends on the old day. This is not chemistry. You did not understand chemical kinetics? Forget about it. Next is P block. Nothing to do with chemical kinetics. Put chemical kinetics in a dabba and move on with P block. Doesn't happen here. One thing relates to the other one. Even though friction is over, but it's going to come a lot more than what it did in the last chapter. Trust me on that. So now we find out the value of kinetic friction, which is mu into n. Mu is 0.1, n is 50. So the value of kinetic friction becomes 5 newtons. Now you see what is the acceleration of the block. 10 Newton is forward, 5 Newton is backwards. So the acceleration of the block, my dear friends, would be 1 meter per second square. That is the first thing that you would have done. And if you could not do that first step, that means we are still not confident about Newton laws of motion. I would suggest go back and see some examples of Newton laws of motion. Anyways, we found out the acceleration. But why did we find out the acceleration? Just like that. No, we have to find out the work done by forces. And if you remember in the last class, we had seen the formula of work done by force. Work done by any force is force multiplied by displacement multiplied by cos theta. Let me not write displacement as delta S. Let me write it as delta R. So I have to find out the displacement of the body. The body was at rest. Now I know its acceleration. Now I have to go back to chapter 1. See, this is physics. Chemical kinetics, dustbin, P block. No, doesn't happen. You have to keep chemical kinetics also together with you because this is physics. This is not chemistry. So now I have to find out the displacement. I know the initial velocity. I know the time. I know the acceleration. I must be able to find out the displacement using the formula ut plus half at square. From there, I will get the displacement. Can anyone tell me what is the displacement?
12.5.
12.5. So I will take that answer as the correct one. Displacement is 12.5 meters with a positive sign because it will be in the same direction. Now I go about finding out the work done by all these forces. The first one is definitely your gravity. What is the work done by gravity?
0.
0. Why? There has to be reason. Angle is 90 degrees.
X-axis.
Gravity is downwards and displacement is in the forward direction. Then we move on to the next one, work done by normal reaction. How much is the work done by normal reaction?
Oh.
It is again 0 because normal reaction is upwards and displacement is in the horizontal direction. This is also 0. Now we move on to the third one. What is the work done by the 10 Newton force? And I apply the formula. Force is 10 Newton. Displacement is 12.5 meter. What is the angle between force and displacement? Remember, the force is like this. Ding, 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 ding. Yes, what is the angle between force and displacement? The answer is 0 because it is going to get displaced in the same direction. Cos of 0 is 1. This is the answer, my dear friends, for work done by the 10 Newton force. Was it so difficult to find out? Is there anything in this question that you did not know how to do? We have been doing this for 10,000 times. You just had to do it for 10,001 time. Anyways, now comes the last one, work done by friction. Again, I have to apply the same formula. There is no different formula for friction. Work done by friction. I have to find out the friction force. I've already found out the friction force is 5 Newton multiplied by what is the displacement? I still know the displacement is 12.5. Then I have to think about the angle between force and displacement. Force is in the backward direction. Displacement is in the forward direction. What is the angle? What is the angle between force and displacement?
80 degrees.
180 degrees. Cos of 180 degrees is minus.
-1.
That is the answer for work done by friction. What is there in this question that you could not have done on your own? What is there? Nothing. The only thing is you don't try. Every question is a challenge for you because the same question can come in the examination hall, and I keep on telling you that is going to happen. You are not going to clear JEE in the examination hall. None of you can do it. Even I can't do it. You're clearing JEE right now. If you are not attentive enough, you are not sincere enough, chances are going to dive down pretty soon. So please, please try, please try, please try, please try, please, 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 please try. That is the only thing that I can tell you. There's nothing more that I can tell you about this. Anyways, I hope you got the answer for this one. Okay. Let's see if we can do the next one. And I hope that we are successful in this one. Remember, this is physics. Chapter number 1 got over 2 months back, but it will keep on coming for 2 years. If you don't remember it, we are in for trouble. This is the next question. A block of mass m is kept on a rough surface. The coefficient of friction is mu. The angle of inclination is theta. This is going to slide down. That is being told to you. It is going to slide down. So don't think that it is going to remain at rest. It is going to slide down. Under what condition it will slide down? That is the first question. Question number 1. For what condition the block slides down? Yes. Anyone remembers it?
mg sin theta.
Mg sin theta is the condition.
Mg sin theta is greater than limiting friction.
What is greater than something?
Limiting friction. Limiting friction.
Limiting friction. What is greater than limiting friction?
Mg sin theta.
Mg sin theta is greater than limiting friction. What is the condition that is going to come from there? See, if you can't remember what we did 2 classes before, how are you going to remember it 2 years from now? I must tell you that from next year onwards, your session will start according to the pre-pandemic era. So you will have your first attempt sometimes in November or December. Next year, November, December, you will be giving your first attempt for JEE. So we don't remember this, see? Don't remember this. Under what condition the block slides down? Thank God I have got a time machine that I can take you back and show you some diagrams that probably I had drawn and you had not. What is this? Sarto writes everything in the damn universe. Why should I write it? Oh, what is this? Stupidity. Angle of repose. 2 classes back we studied this. Angle of repose is the angle at which the block starts to slide down. If theta is greater than the angle of repose, the block will slide down. The same question I asked you today. What? What is this? What type of question is this? Exactly the same question. For what condition the block will slide down? Yes, I again ask you. I haven't shown you all this. What we had done 2 classes before. Just 2 classes before. Maybe 3. Yes, now can you tell me under what condition the block slides down? And the condition is your tan theta should be greater than mu. Angle of inclination theta must be greater than theta report, or tan theta should be greater than mu. Anyways, the block is going to slide down. You have to tell me after when it slides down. You have to tell me a couple of things. You have to find out the acceleration of the block. You have to find out the time it takes to come down. You have to find out the work done by normal reaction. You have to find out the work done by gravity. And you have to find out the work done by the frictional force. I was only trying to concentrate on the 3 question of work done, but now I understand that I had to tell you why will it slide down. That means I have to go back to friction. That's not a good sign. We all have this habit of forgetting things, but this is a um, very big negative that you have if you forget things. You cannot act like Gajini. That movie is old. And if you remake it, it is not going to stand a single day on box office. So this forgetting things is not a good sign for you who are preparing for IIT. Please forget this habit of forgetting things. Forget the habit of forgetting things. Don't forget things. Forget the habit of forgetting things. Anyways, the question is there in front of you, and you have 2 minutes to solve it. And remember, one of these questions is going to land up in your paper. And now I have written an audio-visual proof. Once you are done with your JEE, I'll tell you each and every question that came in your paper, from which lecture, from which part that question was, and what did I tell you, because it is all getting recorded. I'll tell you that. Trust me, I have that much of faith. Chalo, the question is there for you. You have got the chance to redeem yourself. Let's see who all can redeem themselves. I made this as a general question in terms of M, L, mu, theta, so that you understand the question. Maybe the same question lands up at your paper. If you are lucky. If you are unlucky, this question may come in the next day, which you are not going to give. Yes, anyone with an answer? Shall I do it? So I have an answer for acceleration. Okay. Tell me the answer.
Acceleration equals to G into sin theta minus cos theta.
Okay, that is correct. Acceleration is g sine theta minus mu cos theta. Well done. What about the time? How much time does it take to slide down?
Root 2
Yes?
root 2L by G into sin theta minus mu cos theta.
Time is root over 2L by A. Whatever A is. How did you get this? Which equation did you apply? Displacement is equal to ut plus half at square. Here the initial velocity is 0. Well done. Okay. Next one. What is the work done by normal reaction? What is the work done by normal reaction? Yes. No one knows it? Yes. What is the work done by normal reaction?
0.
Work done by normal reaction is 0. Why it is 0?
Perpendicular.
It is perpendicular. Well done. So this is 0. Next comes our old friend gravity. Work done by gravity. Work done by gravity. How do I find the work done by gravity? Gravity is acting like this, and the block is moving like this. How do you find the work done by gravity? How much is this angle? How much is this angle?
90 minus theta.
So what is the work done by gravity, my dear friend? Work done by gravity.
JEE Mains sin theta.
mgl sine theta. That is absolutely correct. mgl sine theta. The displacement here is in this direction. G is downwards, and this angle is 90 minus theta. That is one way of doing it. The other way of doing it, the other way of writing this work done, and let me now take you back to the point where we had written this work done by this force. Now, let me draw it here because there is no space over there. Work done by this force, by any force. We had written this work done as F into delta R into cos theta. F into delta R into cos theta. Now remember, let us say displacement is here and your force is here, and this is your theta. So basically, you can write this work done in a different way as well. How can I write this work done in a different way? Now I can take this F and cos theta together. F and cos theta together. And remember, this force can be resolved into two components. This is F sine theta, and this one would be F cos theta. So my dear friends, I can write this work done as F parallel multiplied by delta R. What does this F parallel stand for? This F parallel stands for the component of force in the direction of displacement. The component of force in the direction of displacement. And now you can see this gravity ka component in the direction of displacement is mg sine theta. You just multiply mg sine theta by your displacement and you get your answer for work done. This mg cos theta component cannot do any work because this is perpendicular. So whenever you resolve force into two components, one which is parallel and one which is perpendicular to displacement, only the parallel component does work, the perpendicular component does no work. So this is another way of finding the work done by any force. You find the component of force which is in the direction of displacement That is the only component that does work. The perpendicular component does no work. So this is another way of finding work done by a force. There is another way of finding work done by gravity, which we will see eventually when things come in that perspective. Okay, that was work done by gravity. I hope everyone understood this. Yes or no? Great. One more thing left. That is the work done by friction. Who is going to tell me work done by friction? Work done by friction. Yes? Am I audible and visible to all of you? What is the work done by friction?
Minus Fk.
Yes?
Minus Fk. L.
Minus Ft. Minus Fk.
Fk.
That's it?
L.
Fk into L. Why minus? Because the angle between Fk, as you can see, Fk is backwards and displacement is forwards. It is minus Fk into L. How much is Fk? How much is Fk? That is the next question. And we have done it 10,000 times.
Mu mg cos theta.
Mu mg cos theta. That is correct. So the final answer is minus mu mg L cos theta. That is the work done by friction. And that completes the question. And that completes the discussion for this problem as well. Do we understand this? Yes or no? I'll give you 1 minute to note down this question. Please note it. 1 minute. So we move on. We have seen the work done by different type of forces. We will write some notes on that as well. We will see them separately under different headings. But let us first write some points about important points about work done, and you must remember these points. So important points that you must remember about work done by a force. What is the first point that you must remember about work done by a force? Yes, anyone? Any idea? You might not have an idea about this, so it is not correct for me to assume anything. Work done is always defined for an interval, whether it is interval of time or between 2 points. Work done is always defined for an interval. There is no such thing like instantaneous work. There is no such thing like instantaneous work. We had terms like instantaneous velocity, instantaneous acceleration. There is no work. There is no term like instantaneous displacement. Displacement is always over an interval of time, and therefore work is also over an interval of time. And that is why I always write work as delta W. The delta tells me that there has to be a difference, there has to be a displacement. So work is always defined for an interval of time, and there is nothing which is known as instantaneous work. Do we understand this? We understand this? So work is always defined over an interval of time. Now, the next point For a given displacement, if you are given that the body displaces from point A to point B, the work done is independent of the type of motion. The body may move with constant velocity, the body may move with constant acceleration, the body may move sometimes, rest sometimes, then move, then rest. For a particular displacement, for a given displacement, work done does not depend on the type of motion. Do we understand this? So, if you are going from your home to your school or hostel, whatever work done, it only depends on where your home is and when your school is, how much you have displaced or how much you have traveled. It does not depend on how you have got displaced or how you have got traveled. Do we understand this? Okay. Then, since it does not depend on the type of motion, then comes the next point. It also does not depend on the time that has been taken. So I go from A to B in 5 seconds, or I go from A to B in 10 seconds. Work done by the force does not depend on time. We have done a question where we had found out in how much time how much work is done. But remember, we found out it not from time, but we found out the displacement between the 2 points, and we found it out from the displacement. No matter how the displacement is, no matter how much time the displacement takes, work done is independent of time. Do we understand this? Yes or no? These are the points that you must always remember. These are the points that you must always remember and never forget, because a question based on this can very well come in any of your papers. Next point, we have already discussed this. If there are more than one forces acting on a body, work done by a force is independent of other bodies, and therefore we can write the total work done is the summation of all the works, because work done by one force does not depend on the other force. We have found out work done by so many forces. When we found out the work done by gravity, we did not think about friction. When we found out the work done by friction, we did not think about work done by the applied force. Why? Because they are independent. Work done by one force does not depend on the other force, and therefore you can add up all these works together to find out the total work done on the body. Do we understand this? Yes or no? It is independent of all those things, but what does it depend on? Work done depends on the reference frame. Why does work done depend on reference frame? Because work consists of two things. One is force and one is displacement. Force, a real force always remains a real force, whatever frame of reference you see. So force is independent of reference frame, and then there is displacement. Displacement depends on the reference frame, and therefore force dot displacement, which is work, it will depend on the reference frame. So work done depends on the reference frame. Do we understand this? Yes or no? Who does? Okay. Now, what is the effect of work done on a system? And we will see it probably in the next class if we can go that far. The effect of work done on any body or any system is that it changes the kinetic energy of the system. And we will see that in a theorem which is known as work energy theorem, WET, work energy theorem. We will see this in a theorem known as the work energy theorem, or the work kinetic energy theorem, which will be coming up in maybe one or maybe two class. The next point is, who does this work? Well, the force or the agent who is applying the force is the agent who is going to do this work for you. Work done depends, or work is done by the agent who is applying this force. Do we understand this, everyone? I hope everyone is noting it down. Now, if I talk about the formula for work done, and in general, if I write this formula, it is force or displacement for a constant force. Now, whenever we talk about displacement, whenever we talk about the displacement, we have to understand in different cases what does this displacement mean. So remember, if the body is moving as a single unit, displacement is same for all points, and in that case you can find out the displacement of any point and you take the dot product, that will be work done by the force because displacement of all points are same. For example, in this question we have drawn this one body. The displacement of all the points on this body is going to be L, no matter where that point is. So in that case we use the displacement of any point. We can call it that the displacement of this body is the delta r. We can use that same displacement in the formula for force, but in some cases there could be different displacements of different bodies, different displacement of different points. In that case, which displacement you will use? For example, and this case is going to come very soon. I have a wall and I have a spring attached to this wall. I apply a force F on one end of the spring. The other end of the spring is attached to wall, and I move this end of the spring, and I move this end of the spring by a amount x. Now, if you look at this spring as one body, the displacement of the point A or where the force is applied, the displacement of that point is x. But if I look at this point, point B, what is the displacement of this point B? What is the displacement of this point B? The displacement of point A where I've applied force is x because I moved that point by x. What is the displacement of the point B which is attached to the wall? How much is the displacement? No one knows it? There is no physics involved here. It's common sense. There's absolutely no physics involved here.
Zero.
Yes, the displacement of point B is zero. That means one point is moving by an amount x, but one point is not moving at all. In this case, how will you find out the work done by the force? So remember, in this case, the displacement x or whatever displacement you take is the displacement of point of application of force. So, whenever I write this formula, work done by a force is force dot displacement. This displacement is the displacement of which point? This displacement is the displacement of point of application of force. Point of application of force. So you must always remember that whenever we are using this formula, we are taking how much the point on which the force has applied has moved. We have to take that displacement as the displacement of the body. It is actually not the displacement of the body, it is the displacement of the point of application of force. If there is no displacement of the point of application of force, no work is done. Do we understand this? Yes or no? For example, if you have a body, say for example, you have some mud with you, okay, mud, and you hold the mud in one hand, and from the other hand you start pressing that mud. That mud actually does not go anywhere, but your hand will go and it will, squeeze the mud or a piece of sponge. Here you can see the body does not move at all, but your point of application of that force is moving. That means you are doing work. Do we understand this? So displacement is not the displacement of the body. Displacement is the displacement of what?
Point of application of force.
This is the body. I hold it like this, and now I apply force. It is not going to move, but it is going to get deformed. Something will go inside. See, the point of application of force has moved. That's why work has been done on this body. Do we understand this? That is how we understand the work done by this body. Displacement is the point of displacement of the point of application of force. Do we understand this? In the next class, we will see that in one case, even though the definition says it is F dot delta R displacement, in one particular case, you cannot even take it as displacement, because if you start to take it as displacement, you will get absolutely wrong answers. So we will see that case, and we will try to bifurcate the work done by different forces under different headings. That we will do in the next class. So we will do that thing in the next class, and I hope that when you go back home, please go through what we have done till now, beta. Okay, because remember, whatever chapters have been done, some portion of that chapter will be keeping on coming in the chapter that we are going to do. So please remember that. I'll see you in the next class. Take care. God bless you all. Bye bye.
Thank you, sir.